Common to try to prove with induction is that certain expressions are divisible by a certain number, particularly if you get into number theory. This is something that is reasonable to do in introductory number theory courses. So to do an example, we're going to say, let's prove that 2 to the n plus 2 plus 3 to the 2n plus 1 is divisible by 7. Okay, so how do we do this? Well, I can prove a base case, right? Here, my base case is going to be 1. What's it going to be? 0. What's it going to be? Well, if I look, I get 0 plus 2, so I have 2 squared is 4, and here I have 2 squared is 4, 4 plus 3, that's 7, that's divisible by 7. Okay, so I'll use n equals 0 as the base case. So n equals 0, I get 7, I'm good. Divisible by 7, obviously. But then I have to say, okay, well now what we're going to do is we're going to assume that 2 to the n plus 2 plus 3 to the 2n plus 1 is divisible by 7. And I want to prove that 2 to the n plus 3 plus 3 to the 2n plus 3 is divisible by 7. Okay? Where the exponents came from us subbing the n's with n plus 1s, right? This becomes n plus 3. This n plus 1 gets multiplied by 2, so we end up with a 3 over there. Okay. Now, this is tricky up front if you don't know the trick, right? So remember, the trick for induction is to always try to get your assumption statement into your proof statement. But the problem is, like, how do we show that something's divisible by 7? Well, let's think about what it means for a number to be divisible by an integer. If this is divisible by 7, then when I divide it by 7, I should get an integer. So that means that I can actually say that this statement, if we're assuming it to be true, must be equal to 7 times some integer. Let's just call it m. So m is an integer. Okay? And if m is an integer, right? It's a positive integer specifically because our base case is 0. Then that might be useful to us, right? Then what I can do down here is maybe I can say 2 to the n plus 2 times 2 plus 3 squared times 3 to the 2n plus 1 is a way to rewrite this. Right? Now I rewrote it this way because it looks a lot more like my assumption statement, so maybe I can make a substitution. And if you're unsure of how I did this, think back to exponent rules, right? The way that you multiply two exponents that have different powers but the same base is you add their powers together. And so that means that if I want to split them up, I just subtract it out, right? So I had a 3 here, and now I took out a 2, and now I'm left with 1, okay? So what you're going to do once you're here is I'm going to say, well, I'm just going to pick one of these. So let's pick 2 to the n plus 2. I'm going to go up here to my assume statement, and I'm going to solve this for 2 to the n plus 2. So I have 2 to the n plus 2 is equal to 7m, remember m is an integer, minus 3 to the 2n plus 1. And then I'm going to substitute this in for 2 to the n plus 2. So I'm going to have 2 times 7 times some arbitrary integer, minus 3 to the 2n plus 1, and then I have plus 9, 3 squared is 9, times 3 to the 2n plus 1. Once I'm here, I'm going to distribute my 2, so I'm going to have 14 times arbitrary integer, minus 2 times 3 to the 2n plus 1, plus 9 times 3 to the 2n plus 1. I can combine like terms here, so I'm going to get 14m plus 7 times 3 to the 2n plus 1, and I'm going to rewrite this as 7 times 2m plus 3 to the 2n plus 1. And now that I'm here, I look at this and say, well, if I divide this by 7, this just cancels out my 7, right? So is this an integer? Because that's like our condition, right? Is it has to be an integer. Well, if I double an integer, I get an integer. And if I take 3 and raise it to 2 times integer plus 1, that's also an integer. So this whole thing here must be an integer. So now I have 7 times some integer p, where p is an integer. So I've proved it. I'm done. I've proven that this is divisible by 7 as well. Okay, so this is the trick, is you always want to write your divisibility statement as the whatever you're trying to show equal to, divisible by 7 and 7 times an integer. Because then in your proof statement, you can get it to look like your assume statement and then solve your assume statement for one of the given things and then just make a substitution. And once you're there, you're just trying to get the thing you're trying to show is divisible out front, so you've pulled it out, and then you just have to show that this is an integer, which it obviously is. And that's how you use proof by induction to prove divisibility.